Good afternoon. My name is Kevin Jones,
Renton Hamilton.
Keyshawn Solomon, and this is our project for QuadSteer, independent steering of electric vehicles. So just a presentation outline, we're going to talk about our background and significance of the project, our motivation and problem statement, our objectives, contributions, time management, methodology, approach, analysis outputs, summary discussion, and our references. So what is independent steering? Independent steering is basically when each wheel on a vehicle turns independently of each other. So the front two will turn and the back two will turn. And this scenario only works when like the car is changing lanes or turning, making a turn. It allows for greater maneuverability and improved handling. Like I said, we have motors attached, as you can see, for our prototype. We have a stepper motor connected to the wheel, which actually turns the wheel forward and backwards. And then we have servo motors connected to the stepper motors, which turns it right and left. So our motivation and problem statement, why should anybody care? So it can possibly increase safety, specifically with the modern environment that's going on today. It helps with parallel parking and making tighter U-turns. And like I said, merging into different lanes. It makes ease with that. It also helps with emergency vehicles, specifically ambulances and fire trucks. It gives them better access to maneuver through traffic so that they're not causing any accidents while they're trying to get to the scene. The cons with this, maintenance and repairs can become very expensive, and the manufacturing price of the vehicle will overall increase.
So the project objectives, in the beginning, we had the big, which we'll see in the time management one is which motors you choose, and also the programming and how we need to do it. Of course, like with research, those are two different motors, separate motors. We had to figure out how to combine the two and learn, of course, how to figure out how to work them separately and then combine them together. And for the end goal, we want to, of course, combine them and have a fully operated electrical vehicle prototype with forward steering. And the side objectives is being able to actually control the vehicle instead of just programming it and implementing this program on a larger scale, so like go-karts and then eventually the cars in the later future. And for the contributions, we all did our part with the coding and designing, research, KJ with the poster and with the building, of the creation of the car. That was one of our main problems that we had to come across. And here you can see is the time management that we took. Of course, the project initiation. How are we supposed to, get all this stuff together? And then the analysis phase, discussing how to go the direction towards our project. And then the programming phase was to, me and Keyshawn, working together with the motors before we build the actual car. And then the testing phase is when we did get the car and we did 3D print it, put the motors on the car, the motor driver and Arduino on there to combine it and to see, trial and error phase, and then implementation after we got everything running. That was the big goal. And here is the workflow of the chart, starting from the beginning of fall semester all the way to April the 25th. We have the studies, we have the time, the development, presentations, we had all the testing and validation, and the monitoring on the project. And here is the methodology. We use Arduino. It's pretty related to C++, for anybody here. Right here is the motor driver. It connects with the servos. So as you can see on here, number from 0 to 15. We have 4 separate servo motors right here to control them, and this helps with the turning. And right here we got the driver board on there. It links with the stepper motors for the forward direction, and we combine all that to get our QuadSteer car.
So for the analysis approach, we use the main motors, of course, for the movement, were the servo motors and the stepper motors. That's what we use for steering, and we basically just got that and make everything together. The analysis outputs, we chose the stepper motor and the main motor for the main movement. We started off with a Arduino Uno, but we realized that the Arduino Uno was a little bit too small because we need a lot more pins for the stepper motors and stepper motors. So we ended up upgrading the Uno to the Mega, and our main program was C++. So for the major findings, we ended up having a small scale. We had a bigger scale, but we kind of split off with the engineering, and the engineers was doing the more bigger scale was the go-kart, and we just ended up doing the RC car. This would help many drivers because it gives us a little bit more traction when it comes to turning and harsher conditions. Say you're in the snow or like in Colorado or somewhere in the snow. It'll kind of help more with traction when you basically going off-road or on-road. Some of the findings, the difficult findings we had was putting it more on a larger scale. So when putting it more on a larger scale, you gotta up the power. You gotta have a bigger stepper motor, maybe different servo motors, and it's a lot more just components you have to put into it. So some of the problems we encountered was controlling the motors. The Arduino code is C++, but it's a little bit different when it comes to variables. And that was kind of a problem when combining the servo motor code to the stepper motor because both of them had different variables. And we figured it wouldn't take too much, but it actually took a good amount of time because we had to add a lot more code to it in order to achieve that. The battery holders, it started off when we bought the battery holders, they were just wires. So when connecting the batteries to the Arduino, it was wasn't giving all the power to it. So we had to learn how to solder and solder both wires together to make a better connection. And this is part of the stepper code. Basically what this was saying is it's gonna just go forward 4,000 steps and that's probably around 4 or 5 seconds. And below, we use a switch case. We could have used an if statement, but a switch case, it makes it more clear to understand and it's a little bit faster than an if statement. And as you see, it says high and low. High and low is basically saying true or false. So high is basically putting the output into the motors and making go, and then low is basically saying it's underneath the voltage, which is basically stop.
And for this right here, these are 2 separate ones. So we're gonna demonstrate a video. For this one right here is demonstrating our crab walk. Like with this function, move servos, it moves like all the 4 wheels. Well, it starts at 0, and then 90 degrees, it moves them 90, like turns all the wheels 90, so it can crab walk inside the parking spot. And for this right here, I use a switch statement. So of course, like if you want to do like a regular car, and you want to control like each tire, like you can. I labeled them the front wheels and the back wheels off the servo motors, So like on this code, it's from number 0 to 3, and I just numbered them. You know, the front, left, made it more explained, and like I use the switch segments to do multiple things with it. And so right here, this one right here is we have a video where it turns, and then it goes back to 0, and then when it comes up to the parking spot, crab walks into the parking spot. So we have 2 different directions, and have multiple. We have 2 wheel steering, and we have 4-wheel steering with the car.
Before we start the video, there are already 2 main cars that kind of have this implemented. So we basically was trying to mimic those 2 cars, which would be the Hyundai and then the Hummer EV, the new Hummer EV. So this right here is the Hummer EV, and then what it's gonna do is basically grab a walk. That's when it goes from side to side. And then there's another view of it. And here's our version of it. And this is from the Hyundai. It's called crab driving. This is where it's going to turn the tires 90 degrees and parallel park. Here's our version of it again. So what ours is doing is it's going to make a turn first, and then it's going to parallel park between those 2 boxes.
From the previous explanation with the servo, that other code that I explained, where it uses the 2 front wheels like a regular car, and then when it gets to the spot, parking spot, and all 4 wheels moving together.
And this is the basic total cost of our final product. Total cost was $140. Our spent the most from the Arduino Mega 2560.